Okay, for this next part of the homework, let's go look at what the assignment says. So for the heat diffusion in Cartesian coordinates with no heat generation and constant properties. So no heat generation means that your Q is going to be equal to 0. Yes, Q is heat generation. Okay, so derive the finite difference. So finite meaning that it's not infinite, it's going to be like some object with a certain size. Form of the heat diffusion equation. Solve and plot the time. Okay, so solve and plot meaning eventually I'm gonna have to program it to plot it. I'm not very good at programming, so that one's gonna be a struggle. A varying temperature profile of the bar. So initial temperature being 300 Kelvin, and then right ends, left and right, raised to 350 and 400 K, respectively. For simplicity, assume that R is equal to that. Okay, let's go to my OneNote and then back to open the OBS recording thing. Okay, so let's go back to okay. I'm going to actually go get the equation from earlier in my, yes, this. Okay, so Control C. And we're going to go to Control V. Alright, so this is from what I'm guessing is going to be the previous video that I haven't edited yet. Okay, so homework 2, and it is, I can't make that smaller. That's fine. Okay, so with this, we have a bar, and we're only going to be in the x direction. So what we're going to do here is, I'm just going to like cross out the y part, and it's not showing up. Okay, it's showing up. So the y part, the z part, like that stuff doesn't matter because it's only a bar. And it's going to be finite, so it's got like 0 to some like distance. Use a lot of D's, so I'm just going to say J, right? And that doesn't look like a J. J. Yes. Okay, so we have our, and then we have our heat, density, we have heat capacity, and then the change of, okay. So what we're going to have, and I'm sorry that this is going to look terrible. So what we have is our K, and then dt, over dx, right? Oh, that's bad. Okay. dx, and it's going to be squared, right? And then you're going to say, oh yeah, and then Q is also 0, so that doesn't matter, is equal to density times Cp. I'm just going to get rid of J right now. Maybe I can make it smaller. I did it! Okay. Times, and then dt, the change in temperature, and that was ugly too. So I'm going to redo it. Time. Right? Okay. So then our next part is going to be, okay, so for this next part, I am consulting the homework. So I'm looking at R, right? R is equal to, and it's an alpha, and then it's the change in temperature over the change in position squared, right? And with this, I realized, oh no, I actually did something incorrectly in my OneNote, right? So if I can go up here, it's not change in temperature squared, it's just change in temperature, right? And so what I'm going to do now is, okay, so it said R is equal to, and then it said alpha change in T over change in X squared. That's not a 2. Squared. Okay, so with this, you know, okay, so dt is going to be this delta t, right, the change in temperature, and this d squared x is going to be your delta x squared, right? And so now I'm thinking, well, where the heck did this alpha come from? What is that, right? So I actually know what alpha is. Alpha, and I hope this looks better than the last time we recorded it, is equal to k over this density and then the specific heat capacity. Oh, it's beautiful. Not really, but it looks better, right? And so that means that I'm going to have to divide this density part right here. Okay, just underlined it. Let me actually keep a look at the OBS so that I know that it's keeping up. Okay, so this this part right here, I'm going to divide it to the other side, right? So when I do that, I'm just going to get the alpha part right here. So I'm just going to do alpha change in T over change in X squared is equal to dt, change in temperature over change in time. Oh my goodness, I've done it. I've done it. Just kidding. Okay, so we're going to have to expand this equation, right? And this is going to be very difficult for me. I didn't know I could do that. Okay, so let's go into text mode so I can move the screen down for my iPad, not necessarily my laptop. So let me go to my laptop and move it down. Oh, so nice. Okay, so we're just gonna keep alpha with alpha, and we're gonna put the change in temperature over change in time on the other side because it's smaller than the other one, and it just makes sense to me. Oh, this is gonna be so bad. I wish I could just write on paper and then turn around. That was a lot of emails. Oh, okay. Well, am I still recording? Yes, I am. Okay, so change in temperature. So you're gonna have a temperature, and then you have over the change in time, right? So you're gonna have a temperature at your time in the future minus the initial time, I believe. Yes. So how we're going to write this would be, okay, so time future n plus 1. Oh, it's ugly. Okay, I'm just gonna put my iPad here and then write. Maybe that'll do it better. So time n plus 1. Okay, it's showing up. And then we're gonna have minus, because we're doing like a change, so that's gonna be minus the thing that came before it if my, oh, my pen turned off. That's why it's not writing. That's funny. N. So n plus 1, n. And then you have over your change in time, right? And so we're going to equal that to, and then, so we're going to have our alpha value. We're just going to keep it alpha because do we keep it alpha? It's a lot of emails again. Okay, so I'm just going to keep it alpha for right now. And then you have your change in temperature over your change in position twice, right? So you're going to have your change in temperature at n. And then let's have j plus 1, because that's going to be like, let's see if I can I zoom in actually? I can. Okay, I'm learning things right now. Okay, so j, then plus, I'm not very good at writing with this thing. I'm sorry. Plus 1 minus time n of just j, right? And so let me draw this. So kind of how I know what I'm talking about. So you can see. Okay, so this is like j is going to be j minus 1. So like position j minus 1. And then position j plus 1. Because it's going to be like after that, right? It's going to be like 400 Kelvin. It's going to be 300 Kelvin. Or 350. That's what it was before. Oh, that's tiny on there. Right? And so with this, you're going to have a change in x. This is the first change in x one. Let's go to text mode so I can move over. And so then, since you have to do this twice, you're going to do, okay, it's writing tjn, which you just had right there, minus, and then you're going to have the one before, so tj, or t, yeah, it's still at the same time, and then minus 1. And so then you're going to have this over change of position, and then all of it over change of position, because it's delta x squared, right? So then let me go into text mode, zoom out, see what I'm going to do now. Okay. Let us take all these x's out, right? Because we need an r, right? Oh, you can't see the r on your screen, but I can see it on my screen. Okay, so we have to have an r, and then r, where can I write it? R is equal to delta change in t over change in x squared, right? Wow. Oh, you can't see the t. Maybe if I put... No, still can't see it as a t. Yeah, there we go. Okay, so, all of these is delta x squared. So you can pull that out. Ooh, it's ugly. This is a struggle. Okay. And then, if we look at the top portion of this, you also have like two like things. So negative t at position j, you have two of those here and here. Oh, that looks nice, than usual. Okay, so then, boy, do I feel silly. It's fine. I'll just correct it later. T n plus 1 minus, it's not writing. I'm going to erase that and zoom in so I can write it. Okay. So so I'm going to move that change in time to the other side, and then I'm just simplifying overall. So t n plus 1 minus t n is equal to alpha, and then so if it's dividing over there, you multiply it over here. Change in t, that's why. So change in t, it's a lot of emails again. And then change in x squared from that one part of the equation, right? And so then I'm going to combine the like terms, as the cool kids say. So t time n, j plus 1 minus, and then 2j, or not 2j, 2 time, or temperature. No, it's fine. Temperature n at position j, and then it'd be plus because it's minus a negative. So minus negative, and then j minus 1 at time n, right? And so I was wrong before. R is not temperature. And we figured this out because we have derived this equation right here. We have, it's not, oh, well, you can't even see where I got it wrong at before, which is good. Okay, so we've derived this equation right here, and I've been recording for 12 minutes. This is awful. And then, so eventually when we're trying to program, we're going to want t, let me backspace it, let me zoom in as well. I'm going to sneeze in a second, I think. Maybe not. Hopefully. Never mind. Okay, so n plus 1 is equal to, and we're going to put this temperature at n, right? Temperature at n is like your initial temperature, right? And then your n plus 1 is going to be like in the future and whatnot. And so let's move over on my screen a little bit, and not ink color selector, and then you're going to have plus your R value times this right here, right? Minus 2t j n. Let's move. Oh, you can't see it because my face is there. Okay, so I have teleported, and this t j minus 1 n. Okay, this was painful. Now, the next part of the video, you're supposed to program. So we'll be right back, folks. Start recording. Okay, so this next part for the finite differencing equation, let's see, solve and plot based off of the profile of the bar, the initial temperature 300. Okay, so what we want to do first is we're going to import numpy as np, because numpy, and oh yeah, and then we need plotly, so import plotly.io as PIO, I'm guessing. So then let's see, we're gonna have to make a subplot. So from plotly dot subplots, let's see, import make underscore subplots, yay, right? Okay, so I don't know how to, okay, So after this, do I even need a... Oh, that's what that is. I don't know what I just did. Okay, so with this, we're going to have a finite bar, right? So we're going to go from 0 to some distance, right? And you're going to have different divisions, like in a ruler. So let's call this, so typically when we program, we use like P or N, so let's use N, and we're using this in the X direction, so NX is equal to, let's say, did it say how many divisions we need in the bar? No. So let's just put 500. And then we're going to say, how do you make text? That's not what I wanted to do. So let's not do that. Hashtag? Hashtag. Bar sections, right? Okay, so then we're going to also have like different times, right? So nt is equal to, let's see, so let's put 1,000 because it's times 2. And then so, oh yeah, let's label it because we like labeling things when we program. Ignore the emails again. Okay, that's a program coach meeting for my scholarship. Okay, so time steps, because we're going to be doing an array eventually, right? And so we have an R value, so we're going to set R is equal to, and then so the first one was 0.1, right? So 0.1. We don't need to label it because we know R is R. And so then we have our temperature. Okay, so since we're doing an array, we're going to do like an numpy thing. Okay, so what is to do an array? Is this how you do it? Object. Okay, that's it. I'm just gonna hope that that works, right? Let's check. Okay, everything's working on the OBS. Okay, so with this, we want the left side of the array, so that's gonna be like starting. So that's gonna be, and since this is what is it called? It starts at 0. The left side is going to be 350 degrees Kelvin. So temperature Kelvin, left side of, was this a bar? I think. Okay, so T, and then so for just like the value that's going to be at the end, just going to put -1 because that's how arrays work in this collaboratory, instead of trying to figure out where it is manually. So then 400, and then we're going to say temp Kelvin right side of the bar. Right? Okay, so then after this, let's see. we need an X value, I think. Okay, so let us look at my thing. Yes, it's beautiful. So you have temperature, initial. Yes, we have a temperature. Well, with it being in the array, it's the 300. We have an R value. Okay. Then eventually, so we're going to have an X is equal to, and then so NP. Okay. Let's see what happens with that. Okay. Cannot interpret. Why not? Is it because of the period? What happens now? $300 is a data type. Oh, it says it right there. So what you talking about? I'm going to pause this while I consult a higher power. I have consulted. I'm recording. I've consulted a higher power. Okay, and I have figured out that I should use full instead, so that it like. Okay, let's just look at what full is. See, let's say like y is equal to np dot full, right? And so it just kind of like a shape. It fills it with it, right? Okay. So then I also figured out that this is a range, not a range, not a range. So there's that. That is what I should use to program. Oh, mashed potatoes. Okay. Can I get rid of this or what? Ah, sweet. Okay. Let's go. And so what we want is we need to make an image. So you're going to use a figure command, and then so make subplot A, and then so then we're going to say that the rows equals, it says 1, calls equals 1. I'm not really sure what this is about, but it says to do that. So, oh, that makes sense. We're only doing one of each. Okay, so then we want to do a scatter plot. Scatter plot? Is that a thing? No? Going to have to consult a higher power in a second, I guess. Let's see. X is equal to X, obviously, and then let's see, you need a comma between things. Y is equal to, and your Y would be like your temperature, because your temperature is determined by the position. I'm recording, right? Okay, we're checking. We're good. And screen is fine. Okay, so then after this, let's see, scatter, and then mode is equal to lines, and then name is equal to, I don't like how this is going. Okay, so naturally, with something where we're going to have to change the position, so like this right here, you're gonna have to have a for loop. What time is it? Almost noon. Okay, that's good. For, so let's use like P, I, P, N, let's see, and then we're gonna have to use NT because that's the time steps. Well, now I don't like the use of, do we have a T that is used? We can say T, or maybe S. Yeah, it's good. Seconds. Yeah, it would be in seconds. For T, and let's see, we're gonna have to say range, and then that range, and then we have to do this because that, and then to be within the for loop, you have to have a tab. So T, and then let's see, from 1 to, my lecture quiz was graded. Yay! See? It popped up eventually. Okay, so to T of, let's see, oh, wrong thing. Maybe I should consult a higher power real quick. No, I think it might be this. Okay, so I'm gonna explain this as I go. I wonder if I can do 2 at a time. No, once I take it out, it takes it out. Okay, so basically what I'm doing here is this. So what you're gonna have is you're gonna have the temperature of a time in the future, right? So that's gonna be, let me just put it right here, right? Okay, so what's it? Oh, I didn't forget the name. Is equal to, okay, and so this is like naturally, so a for loop, so you're gonna have it adding to itself each time, kind of. So you're gonna have this is equal to this plus, and then so you're gonna have your R, which is in here. I don't know why I'm pointing with my finger. In here, and then you have to have this times, and then so you're gonna use this instead. So times, and then temperature at, I'm guessing like J plus 1. So that's going to be the next thing. Okay, and then, so then you subtract 2 times, and then it's going to be the, Cleo, be quiet. Huh? Later. And then plus, and then T, and this is going to be, why do I have an equal sign here? No worries. Okay, let me consult the thing. So this is in the past, so this is going to be kind of like nothing, and then 2. -2. Yes. Yes. Okay, so this is, okay. Hallelujah. How do we do it then? Do this? can't assign function to, wait, I can't assign to function call. I'm gonna pause. Can you even pause on this thing? Nope. I've consulted a higher power and figured out what I did wrong. Okay, so I can close OBS. Okay, so what we did here was we had this there, and it needed to be there. Float object is not callable. We're gonna be what float object is not callable? What are you talking about? I'm gonna consult a higher power again. Okay. I've consulted a higher power and figured out that I just needed to put this multiplication side right here for it to work. Okay, so now what? So our next part I have figured out after consulting a higher power because I don't know how to program or speak. So if I let's see. Floating point number. Let's see. How many time steps do I have? 1,000. So I guess I can make one at every 10, maybe 10 is equal to 0, and then it's going to figure dot add underscore scatter, and then where's my parentheses? Parentheses right there, and then x is equal to x, comma y is equal to t, and then what do we do up here? It's like mode, and then mode is equal to linear, and then let's see, the what is it? Name I think is next, comma name is equal to, and then let's see, name is equal to I'll see if we did that right. And I knew that that's going to be bad. No. Flag list. Lines, markers, text. Must be. Okay, so I shall partake in mashed potatoes really quickly. And then come back after I've consulted a higher power and mashed potatoes. I've consulted with the mashed potatoes and someone with a better programming skill than I, and figured out that is it pig dot show? Is that it? We'll find out in a second if it works. Am I recording? Sweet. Probably wait for this. She'll eat mashed potatoes. and ham. I don't think it's working. Okay, so I figure out I messed up where it said lines. I actually had linear because I'm recording. Okay, and then this, and then we have to have a figure show, of course. And so I'm looking at this. I'm like, oh, okay, well, that's not good. That it doesn't have many lines. Well, it looks like one line. So let's make this like, I don't know, 10,000. Let's make the time steps still 1,000. Let's have, where's the thing that I'm looking for? Ah, yes. So we want it to step every 10. We're just gonna do that. We're just gonna do that, and then wait, do I have to, oh, I think I have to play this, play this, play this, and restart runtime. Yes, please. Excuse you. Are you serious? What did you do? Figure? How? I haven't even changed anything. Make subplots is not defined. What are you talking about? Okay. Just gonna play the first one. Play the second one. Play the third one. Oh, that's what you have to do. I'm just gonna hope that it gets better with time. Maybe I shouldn't have had so many yeah, let's try to change this. We're gonna run everything again. That'll be fine. On the first one, I might have just crashed my computer. Stop it. Stop this one. Oh dear. Oh no. Okay, yes. Yes. Restart this one. Do this one. And then do this one. Oh my goodness. Alright, what did I do now? Okay, cancel. We're done. There's gonna be a lot of editing. So let's try a different number in here because that makes sense to try different numbers. It'll go faster next time anyways. Is there a reason why it's not automatically saving? Oh, I can save my changes. Wait, save my changes. Exactly. Interesting. What have I done now? Consult a higher power. Okay, so I figured out that I can just change this. Run this, run this, run this. Make sure my cat doesn't attack me. Okay! Still not getting anywhere. Not really sure why. Cleo? Here you go. I figured out that I've made one of the silliest mistakes. It's a good thing I'm not in computer engineering, right? No, it's still... Okay. Let's see what happens. Let's see what happens now. Okay, let's go. We finally got a lot more stuff. My cat's being weird. Okay, so let's see if we've done this. Okay, so repeat the calculation. So solve and plot the time temperature with the bar with initial temperature. Okay, so wait, what was the next number? 0.55. Uh-oh. Wait, why do I have so many plots? It's fine. Cleo, stay away. Stay away. Stay away from me. Go. Okay. I'm just gonna ignore the cat. Where's R? 5. We're gonna get something funky. Whoa. What? Stop chewing on the laptop. They're all the same. But yes, it is funky. So, okay. That is the end of 2. Finally, after all of my programming setbacks.